Operation 1. Initial pressurization. To introduce carbon dioxide into the system, connect the CO2 cylinder to the bulkhead situated at the top right of the trolley, behind the collectors. After opening the cylinder, CO2 flows through the pipework towards either a manual valve, MV1, or an optional automated valve, which is controlled through the software. Operation 2. Pressurization of the CO2 pump. On opening MV1, the CO2 proceeds through the valve, passes through the condenser, and ultimately reaches the pump. As the CO2 passes through the condenser, it is cooled to ensure it maintains liquid form. Although the pump can handle compressing high-pressure gas, it operates more efficiently when compressing liquid CO2. Operation 3. Pressurization to the column inlet. The carbon dioxide travels from the pump to the valve marked as MV7, the column inlet. At this juncture, it's vital to avoid starting the pump, as it might unintentionally set off a rupture disc. Operation 4. Pressurization of the column. On opening MV7, CO2 begins to pressurize the column. The column will start to build pressure, reaching around 55 bar, or matching the CO2 storage tank pressure. Operation 5. Pre-pressurization of the Cyclone. To ensure consistent collection conditions, it is recommended to pre-pressurize the cyclones before starting the system. This can be done by opening MV14. By pre-pressurizing the cyclones, the collection conditions are equalized, aiding in the retention of the more volatile components extracted at the beginning of the process. Note: to avoid creating a bypass that directs the collected materials back through the recycle line, it is essential to close MV14 before initiating the extraction process. Operation 6. Opening the column outlet valve. After pressurizing the column, opening MV15 directs the flow to the automatic back pressure regulator. At this stage, the system is now primed, and it is safe to initiate the CO2 pump. Operation 7. Cyclones. The flow of carbon dioxide passes through the automatic back pressure regulator, proceeds into the vaporizer, and ultimately enters the cyclones. Operation 8. Material collection. To collect any raffinate accumulated in the cyclones, simply open MV16. When the cyclones are pressurized, the accumulated material is expelled through the valve into the vent box. The material can then be collected in an appropriate container, positioned below each cyclone. Operation 9. Recycle or vent mode. The operation of the system is governed by two different modes, dictated by the position of the three-way valve, MV17. The valve's position determines whether the CO2 leaving the cyclone will be released into the atmosphere or recycled back into the system. Operation 10. Priming the feed pump. Prior to utilizing the feed pump, it is necessary to prime the lines to eliminate any air within the system. This can be achieved by placing the inlet tube into the feed bottle and opening the right-hand valve, MV2. Once the pump is initiated, liquid will gradually flow through the open pipe, indicating that the lines are now successfully primed. Operation 11. Addition to Inlet A. The level of separation needed dictates where the feed should be introduced on the column. Before introducing the feed into Inlet A, ensure the pump is primed. To introduce the feed material, the left-hand valve attached to MV2 should be opened, followed by MV12. The material moves through the piping, enters the column, and starts mixing with the CO2, thereby initiating its separation process. Operation 12. Feed addition to Inlet B. To introduce the feed into Inlet B, the pump must first be primed. After this, the left-hand valve, attached to MV2 should be opened, followed by MV13. Similar to Inlet A, the material is fed into the column, but it enters at a higher point. By introducing the material here, there's a potential for enhanced separation. This is because the material will traverse a longer path down the column, leading to increased interaction between the CO2 and the packing. Operation 13. Venting the countercurrent column. After completing the separation process, depressurization of the column can be accomplished by opening the vent valve, MV9. The carbon dioxide is gradually released into the vent line. Note: the vent line should be directed towards an area suitable for the release of CO2. Operation 14. Safety. To safeguard against overpressurization, the system incorporates multiple safety devices. In the event that the pressure surpasses the safe limit, the rupture disc swiftly bursts, allowing for the rapid release of pressure.